One of its unique firefighting properties, right? Because it sinks and smothers a fire. Take at home, as part of this LLE, do this demonstration. Take a candle and put it like one of these little tea light candles, right? Or a birthday candle, okay? Or if you can't afford it, a match. All right? Put it in a tall glass. Now, take on top of the tall glass, place another thing, like a non-burnable plate or something like that. Have some distance between the fire and the candle and the thing that you top the glass with, okay? And watch the candle as what's ultimately going to happen. We all know this. If it's sealed on the top, what's going to happen?
It'll go out.
Yeah, it's going to go out. It's going to get smothered. But pay close attention to the flame. What happens to the flame? Now, don't disturb this thing. Leave it sit on the table and close the top and watch it. And do it a couple of times. Okay? So just watch it and have a hypothesis on the front end of what's going to happen to the candle. Okay? And then watch it and see if your observations match your hypothesis as usual. All right.
So our LRE is the candle?
That's part of it. The other part of it is coming up right now. So, density. What would you expect this gas's density to be compared to that of air?
More dense.
So that is a question on this LLE as well. Okay, so what's the density of this gas compared to the density of air? I will tell you that this is an inert gas. It's not like hydrogen. Okay? It's not a reactive gas. And I'll show you, I think this might be interesting.
Balloon animal.
I'll show you, and no, I won't be asking you to blow this up.
Thank you.
You are very welcome.
I wouldn't mind blowing the other balloon, but
Notice this is a lot easier.
Is this the type of air they use for balloon animals?
Nope.
Nope.
Way too expensive for that. So, here is the final observation that you need to make for your LLE. What I'm going to do is I'm going to take this. It's not very much gas in there. But I'm going to take this anyway and try it out. Now I'm going to just tie this one. Come on. That much. This is kind of an interesting thing. Is that weird? Kind of Wile E. Coyote bothers you a little bit, you know? Why do I say kind of Wile E. Coyote bothers you? Why do we laugh at Wile E. Coyote? Because the laws of physics, even though he knows them, he thinks he knows them anyway, they change for him. And that really ticks him off. The laws of nature just don't apply in his world. Well, he thinks they should, but they never work out right. So, I filled this balloon up. I told you it's a chemically inert gas. I'm going to do a little demonstration for you. Are we ready? What's this mean? Okay.
Very white.
Hmm?
Very white.
Alright. Now, the hypothesis here is, what do you think is going to happen? We know some stuff about this gas. Have you ever seen anybody breathe helium? That's an inert gas.
Yeah, they start sounding like a tickle.
That seems to be your hypothesis. If it's everybody's hypothesis, write it down. What's going to happen when Dr. Nye breathes that gas? All right. Are we ready? Time for a little oxygen. Why don't I have to do that when I breathe helium?
Because they'll come out for you.
Oh. Yeah. So, yeah, I decided to get some air, so I did this. And why did I do that? I don't ever do that after I breathe helium and talk like a chipmunk. So, put that in your little observational notes as well. How was your hypothesis?
Opposite.
Now the question is, why?
It's more dense.
But why? So don't answer this now. Try and answer it and do some research. You know, in this day and age, what do we get to do? We JFGI everything, right? Just freaking Google it, right? What is it? Now, you have to realize that not all the answers on Google are posted by geniuses. So you also have to be a little scientifically minded when you read it and try and deduce whether or not these people that wrote this answer have an accurate handle on what's happening. But it's a good place to start. So, think about it. Think about kinetic energy of molecules. Think about how much space they have to move to take up a volume. Think about what's happening. What's happening on the wall of this balloon? Most of the answers to these questions can be found in your textbook, by the way. Go figure. But do think about that. So I'm going to do this one more time, or, you know, if somebody is absolutely...
You should do a ransom call. Call my mom, tell me you got me.
That would be really fun, actually. Your mom would be like, keep him.
She would too.
I got nothing.
He's your problem now.
That's right. I've been paying for this kid far too long. No, I'm just that's impressive, but volunteer?
For sure.
All right. Here you go.
It's not going anymore.
All right.
And I did it intentionally, no.
No, no, really. Now, come on, sing something for me.
I don't see them.
Nobody will know it's you.
Oh.
Now breathe a lot and deep. I don't want you to go clunk. All right.
If you had done it for me, I would have been able to sing in the whole range that
Yeah. I suppose we could do one more shot of this, and then we'll get onto the rest of these lovely slides. Are we ready?
Yeah.
How about, let's see here. Ready?
Let it snow, let it snow, let it snow.
I felt the lights going up. All right.
Wow. Pass out the tank.
So, are we going to be able to answer the questions?
Yeah. Are supposed to answer your hypothesis?
Yeah. It's actually kind of two.
So are we we turning in 2 separate laps or 2 laps and 1 turn-in?
Do you want it to do 2? Let's do 2. Let's do 1 on the candle experiment that you're doing at home, and we're going to call that, I'll write it down. What?
You write that down?
Yep. That's untiable. You pull the little thing, it'll open. All right. LLE number 3, properties of a gas. By the way, the gas, should I tell you what it is?
Yeah.
All right. The gas is sulfur hexafluoride.
Where do I get some of that?
It's expensive as all get out. I think this cost me like $500.
What do you want?
It is, it's special order. You can order it. They may not ship it to you unless you've got some sort of hazmat rating, but it's not really hazardous materials, it's just a pressurized gas. But in any case, it's sulfur hexafluoride. They use it for a lot of industrial applications and things like that, and we use it to demonstrate one of the more dense gases that is safe to handle. So, what's the question you're answering? What was going to happen to my voice when I breathed this gas? And what's the density of this gas compared to normal air? Okay?
Voices. Whoa, what's wrong with you?
Now, not only what's going to happen to my voice, because that's a simple guess. So, voice. What happens? And then, try and explain why. Alright? Now, I'm assuming you guys have this already. It's in your book. LLE number 4. LLE 4 is get a tall glass. In the tall glass,
How tall is tall?
like so, a standard tall glass that you can find. Anything like this is going to work. In the bottom, place a candle, and the candle geometry doesn't have to be anything specific, but let's do this. If you use a tea light, you know what a tea light looks like, right? They're those standard things about 1 centimeter tall. They're about actual dimensions, like this, right? Little wick. Okay? If you use a tea light, place something underneath it at something with different heights underneath it to make a couple of different observations, a couple of different data points. And you might get so far as to do this. So, at 3 different heights, observe how long it takes for the candle to go out. How long does it take to smother the flame? All right? So, you could put in, something, I don't know, a smaller glass, a shot glass in there, if you could find one around here. Or